Okay, so welcome everyone. Thanks for MDENet to hosting that demonstration today. What I'm going to present is the jPipe tool and more generally how one can model justification diagram using such a tool. So first off, why I'm presenting this and why are we doing this in the group? Well, basically, so I'm not a safety engineer, so that's for sure, but my interest in requirements kind of like grew up across my career. When I was a PhD student, like requirements were something you write just to get a good grade in a course, and that was it. It was just like coding, 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 and everything was fine. And then the more I evolved and the more like partners I had, industrial or like public business or stuff like that, the more I realized the interest of working with requirements and defining them and validating them. And now that I've joined MaxCert at Mac, it's really like we're working with automotive industry, nuclear regulator, medical device provider, stuff like that. So kind of like validating those requirements and taking care of safety is kind of like becoming super important considering the kind of like work we're doing. The work I'm presenting today is an assembly of the works of all the people in that slide. Corinne, who actually sparked my interest in 2020 during her bachelor thesis, when she was kind of like interested in working with justification. Disha and Kai were MEng, so course-based master in the group, and they did their project by using the tool to apply for various stuff. Disha was working on continuous integration pipeline. Kai was working on notebooks, and part of that demo is based on the work he did. Aaron and Cass are summer interns. Aaron was an intern last year, worked on the testing of the platform. Cass is an intern right now, trying to answer to that special question that Stefan asked, and he has to remember. And Nirmal was an intern and then research assistant in the group. He's the one who developed a lot of the composition algorithm I'm going to present. So he was supposed to present today, but unfortunately can't make it. And Mireille and Jean-Michel are profs and friends, and they're kind of like interested in using the tool for different things. Jean-Michel with Airbus, Mireille with some of the projects she has with machine learning and things like that. So it's kind of like the jPipe tool as it is, it's kind of like a work in progress that is trying to assemble in a uniform way all those different lines of work into something that is reusable. So it's kind of like a challenge to get this. It's mainly funded by two projects that are really, really different, which kind in a way demonstrate the versatility and need for justification in various domains. We have one project with Francis Bordelot and Jürgen Dingle, which is about DevOps for software-defined network. It's an industrial partnership with a big telco operator. And on the other side of the spectrum, we have this French-speaking project named Réseauté, which is about mental health and natural language processing. And what's interesting here, so it's with Marie-Jean Meurs and Diego Mupome. And what's really interesting is that there's like totally different things. Like there's no real relationship between those two domains, but actually justifications are a way to kind of like unify both works because there's kind of like a need to know what's happening. So I will try to alternate like presentation and demonstration. So first part will be what do we mean by justification? Then we'll go into the demo. And as I was saying to Nuno at the beginning, this demo is kind of like a month ahead in terms of development. So, well, we are a month behind, to be honest. So there are some next steps that are going to be delivered by the end of summer, and I'm going to present them also because I think they're cool. So at least you know. We can go for like the regular demo setup, like I'm talking and all the questions go at the end. We're not that many, so if you want to interrupt, ask question, feel free to do it. Teams is teamsing, so I'm not sure how I can, if I really like, we'll see if you raise your hand or whatever, but really feel free to interrupt, and I will be happy to help answering your questions. So first off, the question would be, okay, what's the common point? You said like mental health, software-defined network, what's happening? So let's go back to the root and let's go back to the definition of safety. If we just take like the dictionary definition, it's a condition of being safe and not causing any hurt, injury, or loss. And there's a tremendous amount of work on safety critical system. It's a very sharp research expertise. Like if you're interested in this, there's tons of papers from some very terrifying, like this one from Phil Goodman, about a robo-taxi crash, like those self-driving taxis in big cities in the US who actually like just drove them across pedestrian at a crossroads, stuff like that. This is getting like very, very scary, and this is related to safety critical systems. But when we think in terms of software-defined network, when we think in terms of mental health and natural language processing, we might not be entirely talking about safety critical systems. It's kind of like very different. So there's using those kind of like all the tooling that comes with safety criticality, it's maybe overkill. So the main question we can ask ourselves is, okay, what does it mean? Like safety related question in the context of SDN, or what does it mean in the context of mental health? Well, in Toronto 2 years ago, there was a 24-hour cell network outage and 911 was not reachable. So during 24 hours, because someone removed a rule in a routing table that everyone thought the rule was useless and no one used it, actually triggered like a domino effect and the whole cell network collapsed for a day. And emergency services were not reachable, which is a problem. There's lots of apps right now working on mental health and helping people during like post-COVID era. And if you look at how those apps are implemented, well, you type your most intimate thought on them and they send to the networks, goes to an LLM. You have no idea what's happening with those data and you become part of the training. So that also, it's not per se safety, but that's something that we're responsible for this as software developer. So this talk and jPipe is not about safety critical system. That's not the point, not even mixed criticality system in the case of NLP. It's slightly different. It's just like we're developers, we're responsible of what we're doing. And if we're just doing things without asking ourselves, why are we doing the things? How can we validate those requirements? How can we validate that we're doing the things for the right reason? We might have problems after. And that's the difference between documentation and justification in a way. Explanation is really about documenting, like this is the way it is, and this is a description of my pipeline, this is a description of my mobile app, this is a description of like everything. And then if we move to justification, which is in a way the next step, it's not only describing, it's really providing actionable requirements validation. Give me a good reason. Prove me that what you're doing is just, right, reasonable in that context. If I have this, I have the why you're doing things. So if I know why that rule is important, I'm not going to remove it from the routing table and my cell network will not collapse. That's kind of like the rationale of the work we're doing on this. So we can take a very, very simple requirements being, I'm a data scientist. I'm working with a Jupyter notebook, which is, we'll see later, but it's kind of like a way to like code your experiment. And I want my experiment to be reproducible. So I have these requirements of the experiment shall be reproducible. I'm working with NLP researchers since 2019, and by observing them and working with them, what you can see is like, yeah, the experiment might be reproducible, and that's the worst case, just like hacked and fingers crossed, we hope for the best. Best case, like 90% of the time, what they're doing is actually reproducible. It's just like the choice they took, the decision they made to make it reproducible. It's inside meetings report, discussion on the Discord or on the Mattermost. It's kind of like, oh, we should do it that way, we should do it this way, but then it's kind of like easily lost. And at the end, you got the documentation of the pipeline or the notebook, but not the rational decision behind those. So you can't even transfer. You need to talk to the person again instead of just having those information. And in real life, those things are actually encoded into shell commands, into API calls, like, oh, to make it reproducible, I need to call that method before this one, I need to do this step before the other one. And that's, again, some kind of like domain knowledge that is accumulated inside teams, but are not really transferable, not really not necessarily documented, but really explained. Like, why are you doing it this way? It's just like common knowledge, but if you're not an insider, you have no idea. So we need to find a way, and that's where jPipe is entering the game, to defend that when we're building software, when we're interacting with our software, what we're doing, being the way we compile, being the way we train it, being the way we prepare the data set, like all those kind of things that cross lots of domain, what we're doing is just, is right, and is reasonable. That's basically the idea. So we ended up with this justification meter model. We are not the one inventing it, actually. It comes from, well, first off, it's called from toolmeans argumentation model, so it's from the 50s. And then that was formalized into so-called justification diagrams by Polacek in 2016. The rationale behind this is keep it stupid simple. So it's not as expressive as other things that we'll see in the next slides, but that's basically the idea of a justification of something leads to a conclusion, and that conclusion is obtained from a strategy, and a strategy works from a support being an evidence, or a support being a sub-conclusions coming from another strategy. For me to be able to present those slides to you today, well, I need my slides to be available. That's my evidence. And also I've signed an NDA with industrial partner. So my NDA is signed, which is another evidence. So I need to have a strategy being like, oh, this presentation can be given if the content is okay with the NDA. So have that strategy that brings me to the sub-conclusion that the content was approved by legal. On that side, I need to check grammar and typo, which means that professional standards, interesting, there's a typo in checking typo. Anyway, the professional standards are met, and then have a strategy being like all my conditions needs to be met, which leads to the conclusion that the presentation is ready. So this is a justification diagram that is actually an instance, a model conform to that very, very simple meta model. There's tons of other way of representing toolmeans like things, because it's from the 50s and it's really basically from ground to a claim through different steps. You might have heard of GSN, Workflow Plus, maybe assurance cases, maybe safety cases. The whole idea is you take a set of arguments, you structure it, and then you say that your system satisfies a set of claim. What's the rationale behind jPipe and justification language is really like, okay, this is really, really like end game level for people who have no idea, like no familiarity with those kind of like safety related and safety concerns. So let's define something which is kind of like a first step, a poor man's language, something which is usable by the average software developer, doesn't come with all the complexity and terrifying number of elements that you can have in a real assurance case to define the assurance of a nuclear center or like space rocket or stuff like that. You just want to say that when I'm compiling that software, I'm compiling it the right way, and that's really the objective. So it's kind of like the easier to apprehend, easier to understand, easier to use is kind of like what's driving us in this. And if people then need something more complex, then it's kind of like, okay, forgot jPipe, it was a bike in the car, just move to real safety-driven or like argumentation model that you can have with other models. Which brings us after this kind of like a little bit long intro of what we can do with the tool, and then what can be what was the next step by the end of summer. This part of the demo is based, as I was saying, on Kai, who's here. So Kai was the one using the tool to kind of like justify things related to notebooks, and Nirmal, who's here, was in charge of designing the implementation, designing the algorithm, implementing the algorithm in the tool, and making the tool available. So it's kind of like he was instrumental in the way this is kind of like available right now. So notebooks. Notebooks, it's basically a way to, it's an implementation of literate programming. Like it's a very shortcut description, but that's it. You can mix code, you can mix text, you can code, sorry, text, results, and you're kind of like describing your experiment, giving some information about it. And this is massively used by machine learning, data science, visualization. It's kind of like very, very classical. From a software engineering support point of view, we do have best practices. We're like, okay, you should do this, you should do that, but those are guidelines. Best case, there's some linter-ish, it's kind of like limited, but there's ways to check. Some of those best practices can be checked automatically. And as a data scientist, as an NLP researcher, as a pipeline designer, whoever I am, my question, and the question we're trying to solve together today is, how can I share a given notebook? I've designed my experiment, it's working on my computer, how can I make it available to others? And not just the result being like a PDF of the execution, but really like the code and the execution of the code. How can I make this shareable? So first off, to get jPipe on your computer, jPipe is a DSL, which is written in Java Antler, pretty basic stack. You can get So the compiler is standalone. You can go to VS Code and get the extension, which is a language server using Lever, something which is internal. And then that gives you basic support like syntax highlighting, code completion, fold, unfold. So basically, let me go. So this is a website of jPipe where you can go here. There's some release. New one is coming soon, but that's what we have so far. On the marketplace, if you look for jPipe extension, because jPipe was already used, you can find this. And it's a work in progress. Like we do need the logo, we do need some information there, but that's kind of like something you can use. This is the first public presentation of jPipe so far, so it's kind of like really fresh. And if you're in the demo today, you have, I put on the chat all the codes and everything, and you don't need to matter installing because I gave you kind of like a jar that is already pre-compiled. So you can just like clone the demo and run the stuff. As soon as you have a Java 22 installation, that should be okay. So assuming you have jPipe on your computer, well, you do have a DSL that helps you instantiating things conform to that meta model. So if we take the jPipe extension, which is here, and we'll take the quality, which is here. So basically what you have, I can try to zoom a little bit. So what I'm saying is that my notebook can be shared because I'm meeting some quality gates. And for my notebooks to be shareable, the execution environment should be reproducible and the code quality should be fair. How am I checking this in that particular case? Well, the reproducibility comes with one of the best practices from the literature, like the notebook needs to have a linear execution order, and the code quality, I will just go like, okay, just write me decent Python code. That's fine for the level of expertise of your team. So I just want to check that you're conform to PEP 8, which is standard in Python for this. And both strategies relies on the fact that the notebook file exists and is available. So based on this, I can have my justification, which is here, like fold unfold, and I have my evidence, which is a notebook file exists. If I blah, 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 then this is reflected on the diagram on the right. And conclusion gate, and I have my like gate support shareable things. If I want to compile the thing, so I can extract this from the editor, but I can also just ask my compiler to do it. So let's run jPipe. I'm interested in the justification diagram named notebook quality, which is this one. I want an SVG file, can also ask for PNG or stuff like that. This is my input file, and I want the output to be named full.svg, which is pretty straightforward. And then I obtain this very diagram here. The compiler kind of like give you some information, like for example, if I try to plug, I don't know, gate into an evidence. So gate into notebook. The compiler just said like that does not make sense, and I can't really do anything. Or you can be like gate supports Smurf, and it's just gonna, ideally, and in the next version, you will have like red lines here saying you can do that. But if you run this, you get an error message saying like, oh, there's top level error. You can't create relation between non-existent argument, and this is line 14, which is what's happening here. So that gives you this kind of like information. You also have kind of like, you want to refactor this being now Smurf, so everything is transformed into a Smurf, like those kind of things. Here we go, and here we go. So the DSL will like immediate translation of the meta model, and that allows you to define those kind of like things. What's interesting here, and what we're realizing, what we're working on this, is like this mixes different expertise. The fact that the execution environment is reproducible, that's kind of like concerns from data scientists. It's really the way you're preparing the data, the way you write you organize your experiments. So that's one kind of expertise. And this part, the fact that my code quality is fair, it's more about the coder, so the software engineer, software developer who's actually writing this. Might be the same person, might be a different person. You might have a data scientist designing the experiment, and you might have someone who's in charge of coding it, which might be slightly different. That might happen if the team is pretty big. So basically, in that case, what we're realizing is that we can do separation of concerns. We can make kind of like our justification additive in a way, just by having those kind of like, okay, I have something related to reproducibility, I have something related to fairness. So let's try this. I'm a data scientist. I'm interested into the fact that my justification needs to be reproducible. My notebook needs to be reproducible. Well, I can write that argument. The file exists. It has a linear execution order. So I have the set conclusion that it's reproducible, and with all the other quality gates that might exist in the project, the notebooks can be shared. So that's kind of like the way I can design this. And you see it's evidence EC, it's like written by someone. And then you have another one, which is fairness. You'll notice that when I clicked here, it's kind of like recognize I'm inside fair. So it like changed. And if I'm going back here, it will actually go back to reproducible. So I'm inside fair, my notebook exists, I'm PEP 8 coding standards respected. So the code quality is fair for that team, and quality gates met, notebook can be shared. And if I want to assemble those different things together, like you can things like off-the-shelf best practices, and actually those two best practices comes from the literature, and we've studied like 20-ish in Kai's work. Well, I can actually define the fact that shareable is basically reproducible with fairness. That's my definition for this team, for this project. If those two elements are met, then I'm fine for that team. So if I go here, it triggered the merging algorithm, like the composition algorithm of creating a justification by assembling those. And that gives me the initial one that we had. But this one, I've defined it by accumulating different proof or evidence that my notebooks can be shared. So this is how we can use separation of concerns in the context of justifying. And this works because actually, in that case, we're really in an additive model. Like justification we're building is additive by nature. So it's kind of like, oh, we want to add this, we want to add that, because we have this kind of like quality gates are met here, kind of like assembling everything that are actually isolated concerns. So this is how you define this. And the last part that I wanted to show is another way to structure your argumentation. This notion is actually a trick, because to be able to do that, I had to define my justification in a way that make them composable. And also because I have this assess quality gates are met that's used as an end on each and everything, I can be really additive. But sometimes you need a better structure to kind of like be sure that the way you're argumenting, the way you're defending, that you're doing things the right way makes actual sense. So this is where patterns come into the game. The idea of a pattern is to give you that structure, which might not be additive. It's just like, I need those. So I kept the same example for the sake of clarity, but in that case, I'm just saying that my notebook can be shared if I'm assessing all quality gates, and I need a support saying that I'm reproducible. Do it the way you want, I don't care. Just like at some point, you need to prove me that your environment is reproducible and tell me that your notebook code quality is fair. Again, use whatever method you want. It's just like, I need those two to be able to conclude that my notebook can be shared. You can see this as a guideline at the company level, like, oh, we want all our notebooks to be shared or inside a research team. But the way you're going to do it might actually depend on the team, the project, the product. Like there's lots of variation that you can have. So this is the patterns that, oh, for sharing, use this, and the language will help you to do that. And the main thing is like, you can think of it like an abstract class. So this is an abstract element. It's named add support here. And like, I need it in my real justification, but inside my patterns, this is just a step that one can provide. So in the tool, I can go to my pattern. Here we go. And that gives me those two. I have the stereotype here saying that this is a pattern. So per se, it's not really a justification. And I can go back to my PEP8 linear, which was, okay, my notebook is reproducible because using linear execution, and its code quality is good because using PEP8. That's my implementation of that pattern at some point. So if I go here, then I have this kind of like shareable elements that is provided. And what you see here is that the justification just fill in the blanks. It's like, oh, there's a sub-conclusion, which is reproducibility, and this is how I meet this condition. There's a sub-conclusion, which is fairness, and this is how I meet the rest. How I meet that conclusion, sorry. The rest, the conclusion, the strategy, and stuff like that, this is part of the pattern. So I don't care. I'm just telling you how I'm reaching this and how I'm reaching that. And I can have another implementation of this. I can be like, oh, I will use a totally different way of implementing this because in my team, we're working differently. Like the reproducibility, in my case, this is just to check that all my dependencies are pinned so I can re-execute my notebook today or in 3 months because I've specified that NumPy is version 2.7.3 so that in 3 months when that version number will have changed, I will still use the same one. And my code quality being fair, well, I don't really care about the code quality, but in that case, I really care about the fact that paths of data sets are available inside the notebook, so they're not like going everywhere. There's no like hard-coded paths. So I can verify static paths, and that can be done automatically. And I can also ask the developer to swear that they're not, when they're building dynamic paths, like using code to decide which path to go to, they're staying inside the notebook, the directory, and they're not getting outside. So it's kind of like just another way to realize the same pattern, which is reproducibility and fairness give me, and code fairness give me to the, leads me to the conclusion that notebooks file can be shared. And that's it. And if I, for any reason, do something which is I remove this or I'm doing something else, the compiler will just refuse to compile, being like, this is not compatible with these patterns. You have to prove me how those things are reproducible. Like we can actually remove this, for example, and we can try to compile. There's a shortcut in the compiler. If there's multiple diagrams and I'm interested in everything, I will just use -all, and that will just dump all diagram in the current directory or the provided directory. So it's just a way to avoid calling the compiler for each diagram independently. And if I'm running this, well, it's a strategy can only be concluded by a sub-conclusion, and you're giving me an abstract support. So I can't, this is not legit. Your justification just does not make sense. And so that's the kind of things we're looking for when we're instantiating a patterns. Like we need a support for this, like a real one. We need a support for this, like a real one. And this is actually how the final one is done, by rewiring the patterns and the different things. And we only fill in the blanks. That's what I was demonstrating. You have the slides and you have everything on the jPipe demo website. You can rerun the experiments. You have for each justification, you have how to compile it on the top. The README is pretty minimalistic, but that gives you also how to get jPipe on your computer, how to run the demos. The slides are the slide I was just presenting. And if you want to recompile the language server, work with those like anyway, those are kind of like some extensions, some instruction to do it on your own or on your own machine, or stuff like that. Quickly, what's next and what was supposed to be ready for today, but will be by the end of summer. First off, we're working on a more extensible version of jPipe. What we have so far, it's really like, give me a justification. I can check its consistency, syntactical, more or less, and I can produce a diagram. That's it. We need a little bit more to be able to support more integration and support better reasoning. We have lots of use cases coming from machine learning and continuous integration where we need reasoning and we need automated verification on those diagrams. So we're currently refactoring the compiler to work as a library. So you will be able to interact with the compilation chain. You will be able to add your own processing, like, oh, I want to generate some YAML code. So bam, just write your transformer, put in your own compilation chain, and you will be able to do that by using the whole platform that is provided for you. And we also want to support like more yeah, more integration in a way, having a way to integrate with other environments. So what we have, for example, for the notebooks is the idea of creating a software product line of best practices, and you just decide which practices needs to be used by your team, and we actually assemble for you the argumentation, just giving information about how and why your notebook can be shared. And to go into the automated validation, what we want to do is actually provide a way to annotate with execution environment information, those different things. If you tell me that your notebook file exists, just tell me how to check this. It's just like shell command that check that, oh, this file exists. You want to verify that the notebook has linear execution order, it's your strategy. Is this automated? Can we automate this? Maybe. And if we can, just give me the command. In that case, we're calling notebook linter called py_lint, and this can do the job for us to check this. You want all the quality gates to be met? Well, just check that all execution were okay, so the exit code was 0 and we're fine. And so with this, if you annotate, like you have your justification, which is domain independent, and then for your given project, you just tell me how to automatically check this in your given context, we can actually generate the YAML template that gives you continuous integration for your own project. And then you can check those quality automatically. We have, like, so far we have the implementation of the target, where I just need to get like the new transformation working with the new compiler architecture. And finally, which is Stefan's question I was teasing at the beginning, the current language server that I just demonstrated, it uses Lever, which is Alexandre Lachance's math thesis. We demonstrated it on that channel a couple of months ago. And at the end of the presentation, there was a question from Stefan, which is, oh, wouldn't it be easier to retrofit your grammar using Lengium instead of creating your own framework? That's a totally legit question, and that's what we're doing right now. We have this version that is working with Lever, and Cass, who's in the call, is an intern in the group, and she's basically doing the same thing with Lengium. So that gives us a way to compare, and that will hopefully by the end of summer give us a way to answer Stefan's question. And the spoiler that it's far from being that simple, and devil's in the details. To conclude, it's a first step towards redemption for engineers to just like not document, just tell me why you're doing things, and then we can help you into automating this. We can help you into validating the way you're building your software. We've demonstrated this today on scientific notebook development, but there's like tons of other cases, continuous integration, software-defined network. Lots of things requires you to actually tell me why you're doing this. And we used the work from Nirmal on composition models and patterns to find a way to organize this and to implement this in the language. There's more cool stuff that is coming. Soon a new release. We're targeting like mid-summer-ish to have like the last features I was describing. If you're interested in things related to this, shoot me an email, go to the website, play with the demo, submit bug report. There's some. We have some paper-ish. It's preliminary, but that's actually pretty like nice. We have one at Conflong, which was about how can you justify your configuration to avoid like cell network outage. Corinne Pulgar won the bronze medal at ACM SRC at Models 2022, and we have both MDENet report for Disha and Kai on using justification for 2 different domains. And just some blatant advertisement that we're hiring and we're always looking for people, faculty, postdoc, PhD, master, interns, whoever. Just if you want to do some cool stuff on model-driven and software engineering, shoot me a message, contact Richard, and we'll be happy to kind of like answer and help you if we can. Thank you very much. And I think I was like around 30 minutes as planned.